Engineering Group Meetup. My name's Peter Robinson.
And I'm Brett. I work at Pegasus, which is the protocol engineering group within Consensus, focused very much on a newer Ethereum client, Pantheon, but also the future of Ethereum. Things like Ethereum 2 and what we're going to be talking about today, Ethereum 1.x.
Cool. All right. Well, that's awesome. And so please keep watching the video. It's going to be starting, the talk will start in about, what, 10 minutes or so, maybe 15?
10 to 15 minutes.
10 to 15 minutes. So just fast forward on YouTube, or we'll see you there. Okay, thanks.
Thank you.
Hey guys.
Hey,
Hello.
how's it going?
How's it going? I'm Sharon.
I'm Peter.
Nice to meet you.
Brett.
Sharon. Nice to meet you.
How's it going?
Is this, I'm assuming you guys have been running this for a while, or is this
For a year.
For a year now.
Yeah.
But this is the first one for me.
Yeah.
Okay.
Oh, welcome.
Yeah, and so we're live on YouTube right at the moment.
Oh, nice. So you normally cast this live?
Yep.
Yeah, we try to cast it live, and sometimes the live fails.
Okay.
At which case we re-record.
But yeah, but right at the moment I'm watching it. So one of the watchers is me. In fact, there's only one at the moment.
I'm super hopeful it does record live, because I tend to just make these things up as I go along a little bit. So repeating the exact same thing probably won't be the exact same
Well,
thing.
these talks go so much better when you've got a live audience. And so even if we do a re-recording, invariably we have about half a dozen people on the record.
I'm generally a fan of actually rocking up, because there's a certain aura about a person who's presenting that you need to absorb to really connect, and you don't get distracted if you're just looking at the screen and stuff like that, right?
Yeah.
So while watching it on YouTube is convenient, you don't get the most impact.
Well, the other thing too, unless you edit the video specifically for an audience to watch, so you have the the slide deck, and then you have either cutaways to the person talking or them permanently on a small part of the screen. So we tend to have this zoomed in on this.
Okay.
What ends up happening is the presenter, unless they're standing behind a lectern like this, is animated in some way, and you lose all of that.
Exactly. Right. And plus, I mean, like when you're watching it live, you have a choice between looking at the slides, looking at the presenter, and shuffling between.
Yeah.
Whereas you don't really have that unless, as you said, there's live editing happening by somebody, so that you're actually producing the content, which is too much effort. Yeah. So.
Fantastic. So what's your involvement in Ethereum? What do you do?
So I'm a software engineer.
Okay.
This has been a space that I'm very, very interested in, but I haven't done anything in making that first move towards developing on the platform. So my interest lies purely from the development space, because I kind of look at this as the next big step in general evolution of tech in general. Right?
Yeah, definitely.
Distributed computing and stuff like that, that's always been something that has been of interest to me. But it's never been truly distributed. Right?
Yeah.
There's always, when it comes to, building a business around an idea or concept, most people start off with noble intentions, but then as soon as, you get money involved, then you need control, and when there's control, then, it needs to be centralized and stuff like that.
Yeah.
Whereas, crypto and the platforms in which they run are distributed in a very essence, right? And and it's gathering traction now, right? So
the concept is totally, whether it's Ethereum or other blockchains or concepts, the concept behind it is a bit like to my mind, the stage we were at the mid-90s with the .com. We have static HTML, and then people said, well, hang on, how can we wire these things up to be not static, and what does that mean? What can we do with it? And 10 years later, we have the birth of your phone with all the apps starting to be on it, and things like Facebook and eBay and other stuff are starting to be what we just expect to happen. I suspect we're in a similar sort of timeline with this thing, maybe in a contracted stage. But the meetup itself, the majority of the people, especially those with Pegasus on their shirts today, we're building the actual client. So that depending on what your background is, my first foray into it, I heard Ethereum client. I said, well, what's the server? It's like,
exactly.
it's not, it is. It's, there's, you know, there is no client server model. It's a node is the best way I think we should probably start talking about it. And so you've got two types of developers out there. You've got the people who are building solutions to run on the blockchain, which will usually have some element of smart contract. And then you've got people like ourselves who are, most of the people you'll meet today here, are software developers who are writing anything which is a enterprise grade Ethereum client. So, you know, that's the client itself. That's actually, so we don't write, well, that's not completely true. We don't write applications running that use things, Solidity and WebJ and all that sort of stuff.
So the assumption is that all of that exists, and yours is the client that interfaces with
ours is
people to the blockchain, connecting people to the blockchain.
Well, yeah. So if you think about the clients out there, people like Get or Go Ethereum and Parity, Pantheon is a competitor in that space. If you want to, competitors is a very harsh word, but you know, it's basically at the moment we're all competing to try and make Ethereum successful. At some page, Ethereum becomes successful, and then we all compete to say where the best. It's basically like the browser wars, right?
Yeah.
Actually, that's the other way to think about it. I try to think in my head is that, you know, Firefox or Netscape when it first came out, you know, all that sort of stuff were the browsers. People didn't think about the browsers. They still needed to evolve, because if they didn't support the things you wanted, you couldn't write the applications you wanted. So you've got your app developers, and you've got your browser developers, so you've got your app developers, and you've got your client developers.
So client dev would be a web app.
Ethereum and the technology behind it. So the one we had last week was talking about the architecture of our last month was talking about the architecture of our product Pantheon. What is a Ethereum node? What are the bits that make it up? Today is more about protocol and future acceleration. But if you're new to the space, the first part of the talk will kind of give you a snapshot of Ethereum in general. So I like to take people on the journey of actual people that have thought about why.
I was just saying, Peter, I went down to the ground floor because
Yeah, we'll see how it goes. I had hoped to do the proper screen presenting thing because I've got the odd little note down there, so I don't have that option in this system. We should see how that ends. I'll have to just run the show and make sure that we've got it right. Yeah, there is, but I
Third for the year. Yeah, there's a whole 20 or so from last year. Yeah. But yeah, I mean, this is the beauty of doing it every second week or every fortnight. You end up having quite a few. It's having that rhythm one, people know when there's going to be something I should turn up. It's easy for it once every 3 months. And there's just so much to talk about that you know it's easy to come up with topics. Yeah, it's really good.
Are they doing the Ethereum 2 or whatever that's on the show?
Yeah, so I did the Ethereum 2 last year, which was the intro to Ethereum 2, what is it at that point. And then I'll touch very briefly on the history of Ethereum 2 up until the end of last year in here, because that explains why 1.x is coming around, or why it's being discussed. And then, so I did that one last year. I'm doing 1.x now, and there's another one scheduled later this year, which is going to be an update, because things are changing constantly in the space, and we want to know, well, where is the theory now versus where are we actually practically. that'll be fun, because I need to go into the way the R&D team does and what the latest is with respect to this. Because we've got most of Pegasus is kind of split really into two areas.
Now, in the one you had last fortnight, we were talking about you were talking about force and smart contracts. So for smart contracts, are you honouring the code? Yes.
Yeah, because you have to. For us to be a client, for us to be able to participate on mainnet, we have to implement. So there's a yellow paper, which defines a lot of the stuff around what the EVM codes are, the opcodes, and so we've had to basically write an EVM to be able to have client. So yes, we can run those. I'm just going to go and change a date that's just been pointed out to me. I'm an idiot.
You would know lead out of that.
There we go. One Lucas coin to the person who kicked the mistake. Yes.
Please grab a seat.
Sally, I think you need to check. I don't see it. One Lucas coin.
Still another minute or two.
Still another minute.
There seems to be people coming through, and it's still quite complex to get to. So.
It's yeah. The hard part is just knowing when people have arrived and if anyone else is going to turn up.
Yeah.
Because at least if you've got a front door, you can see people meandering towards you. Here it's a bit hard because they're downstairs. Yeah.
They did put a sign up as I walked in saying the Meetup group isn't here and stuff like that, so it was fairly easy for me. I usually find the first session always has the little paper.
But it's going to tell when do we actually move again?
At the moment, I think I might end up booking this room for the rest of the year and just be done with it. It's hard, it's complex to get to, but at least everyone knows where they're going.
Well, you've got to be careful because it becomes really problematic. You may have a seating capacity.
Yeah, and that's the challenge with this space.
Yeah, this is true, but
I guess if we get to that point where we start to find that there's not enough seats for people, then the next one we just work out that we can book the other space and we transition.
yeah.
And you never know. The challenge with a lot of these things is you might get an influx of people interested in that topic, and the very next one, it's at a level that the people who were there last time aren't interested in that one, so they don't turn up.
Yeah. So the applications one, which is in 2 weeks' time, I know we've got a lot more people than for this one planning to come along. And because people want to know what can you actually use blockchain for, give us an example. And so we've actually got 3 now. Yeah, we've got 3 really good use cases. So we're going to have Union Bank example from Chris, and then we've got the one that Richard's doing that is finance and fintech, and then we've got.
Okay, good. I'm going to throw you on that last slide you added around what's coming, because I actually didn't get to read that before I got here.
And then we've got the research one coming up as well. And if I haven't mustered up enough researchers, then I'm going to present cross-chain, because by then there should be a paper out on archives.org, and that should be pretty good.
Cool.
Speaking to this one, I'm actually curious on what
Yeah, the next one is, that's going to be that interesting one for you to see the difference between the client development, which we did last time, versus the application development of writing solutions to on the blockchain. And that, all that would be around stuff that we do in Ethereum. Most people do in Ethereum. You can translate that to another blockchain realistically. Because it's a concept, like the .com stage, and one of the things that worries me is people are going, I have to have the word blockchain in my marketing material so that people will invest in it. And it's like, yeah, but you don't need blockchain to solve that problem. So pets.com, you will ship pets around the world, you do what?
That's cool videos, but
Sorry?
They had some cool videos.
Yeah, they did, didn't they? Yeah.
The government's, well, I think the CSIRO with Data 61's come out with, should you be using blockchain?
I think everyone's going to have different opinions and everything. It's going to evolve.
UQ's doing a whole PhD on a framework for assessing whether you should use a blockchain. And so she's written a few good papers on it. And unfortunately, she's going to be busy on the day that we're doing the research thing this time coming up. But it could take her job. You know, like, this is my analysis framework.
Well, we're just after the half past.
Yeah,
Do you want to kick this off?
I think so. Yeah.
Cool, let's do that. Okay, everyone, we're going to kick this off. There might be some stragglers, we'll see what happens. Most of you know me. If you don't, and for the second half of the recording for people who just joined, so my name's Brent. I work with the protocol engineering group, Pegasus, within Consensus. We're building an Ethereum client, or have just released an Ethereum client, version 1, enterprise grade, and continuing to work in that enterprise space to build out a solution that companies, as well as working on mainnet, can work on private chains and so on. A number of the team who are in the development team are here in the office with us today, which is fantastic, because I can throw all the deep technical questions to them, specifically the smiling one down the end there, who's done a lot of POC stuff. Thanks for coming out. But today we're going to talk about 1.x, and this is a relatively new thing in terms of the community. You're starting to hear a lot of terms of 1.x. People will have heard of version 2.0 and what that means, and we'll talk a little bit on that in a minute. But today we're going to go on with a journey, brief history, so giving you some context about timelines and why some of this stuff is now happening. Then what is really 1.x all about, and then a dive into a closer look at the 4 parts that make up 1.x as it is today. And then a little bit of what's next, including possibly a journey for yourselves. So let's start off with a brief history. In July of 2015, Frontier was released, which was the first mainnet version of Ethereum, as we know it today, Ethereum 1.0. And after that, we had Homestead came out around March, which brought in some improvements in our transactions, processing, security, etc. And then there's, if you notice, the timeline is getting longer. Byzantium came out in October 2017, so we've got quite a decent breadth of time there before that came out, with the extension of the difficulty bomb being an indicator of things aren't quite where we hoped Ethereum would be by then. For those who don't know, the difficulty bomb is about that extension of, well, the difficulty bomb idea was to force the move to proof of stake. So ramping up the difficulty so proof of work becomes not really viable in the environment. And then, I think last week, Constantinople finally made its appearance after a slightly aborted attempt earlier this year. And again, the difficulty bomb got pushed out. And so the reason I wanted to start with this slide is just if we look at 1.0, the timeline is quite significant, and there's some improvements to it, but it's not necessarily the improvements that we may need to overcome the challenges that we'll talk about in a few minutes. And so Ethereum has been growing quite significantly. If you ignore the couple of early spikes on there with the DAO and a few other things, and then there's this ramp up in 2017, and then it got super excited when CryptoKitties turned up. But it's kind of flattening out at around the 80% utilization. So people are using it, but we're starting to hit up against a couple of limits. So Ethereum 2 was proposed and has been a work in progress for a little while. And it's got 3 main areas that Ethereum 2 is trying to address. It's trying to address that scalability. So currently, depending on who you talk to, around 15 transactions a second go through mainnet. To put that in perspective, PayPal is about 193 transactions a second, and someone like Visa is about 24,000 transactions a second. So if we want to see Ethereum become that next generation for transactions on a network globally, we're going to need to start to ramp that up. Proof of stake, we just talked about that. Proof of work is there, but proof of stake brings finality and security, which proof of work doesn't necessarily give. And it also fits into the last one, which is really that decentralization. So right now, you have to have a fair amount of specialty hardware to be successful as a miner. The goal with proof of stake is that commodity hardware would be there. We're not here to talk about 2.0, but we do want to think about what 2.0's history is like, because that's leading us to another fun story. 2.0 was first mentioned way back in 2014 as it's going to be the next gen after we get mainnet out, and it'll be out around 2016. And then the second half of 2017, we finally had the two major pieces. So sharding from a scalability, Casper from a proof of stake were starting to finalize, and we might get somewhere. And then just before a major conference in Taipei, there was a whole new proposal for sharding came out, so that derailed that conference a little bit for the positive. And then, you know, Casper couldn't get left behind. Casper came out with some new proposals as well, not long afterwards. And then my new favourite term, Shasper, turned up in around Berlin, which is that merging of the two. So as you can see, we got a long period of things are stable, and then, oh, look, everything's just gone a little bit interesting. So towards the middle of last year, we're starting to finalise on maybe what 2.0 might look like. Which brings us to the latter half of last year, and 1.x. So DevCon, the major developer conference for Ethereum, turned up in Prague towards the end of last year, and there was a couple of ad hoc meetings. The first one, which really started this whole game, was to say, well, let's get the people who are talking around 2.0, because a lot of the R&D and core devs people were there. Wanted to find out what this is going to do. Where's 2 at? How long is it going to take? What's it doing? And the timelines were questionable. Various people have different opinions, but we're talking potentially between 3 and 5 years before we see a 2.0 that completely replaces what we have today. That's not to say that things like Beacon Chain and other elements of the 2.0 won't appear, you know, throughout that time, but to have it fully functionally replacing, the numbers could be 3 years away. And we have a network that, as you saw, is already starting to struggle a little bit for growth, and we want it to continue to growth, right? So the next question that came out of that was, well, how about we introduce something in parallel? Can we do some things today to improve on Ethereum 1.0, and what might they look like? So the outcome of those initial few meetings was a proposal that a 1.x is done in parallel, and that a couple of working groups around some of the elements, which we'll talk about in a second, that we could look to introduce to 1.0 over the next little while to keep it all going well. There's been subsequently 2 more meetings. There was a proposal meeting that happened at the end of November where basically the working groups presented their proposals, and I've drawn heavily on a lot of that for this presentation. There was also the Stanford Blockchain Conference in the end of January. Just before that, of course, you've got the whole community who's interested in this space are going to be there, so there was a number of talks and working group FaceTime conversations happening during that. But what is 1.x? Well, we've talked a little bit about this already, but I want to reiterate. We're seeing some performance degradations, mostly due to an increase in state, and I'll talk about state for those who don't know a little bit later. We've also seen an increase in storage, so if you're running a node, you have to have bigger and bigger disk capacity to be able to scale for the growth that's coming. The objective of 1.x, and keep this in mind as we talk about a lot of this stuff, was essentially defined as developing and formalizing and implementing within the next 2 years some solutions that give life to Ethereum 1.0 while we get 2.0 out the door. Alexi's quote I did like was ensuring the longevity of existing Ethereum network. So keeping what we've got going until we can upgrade it to deal with the overall long-term growth. The design principles that they took on board when they set up the working groups are fairly straightforward. You want small incremental updates, as we saw earlier. Big timelines between some of these updates. So if these updates are going to take forever to do, we're going to be stuck with these big long ramp-up times before we see any improvement, and that has an impact on the credibility of the network. A sense of urgency. We don't want to basically just have this thing going forever, but we are affecting the community and we're affecting the public who use it, and so we need to ensure that they're taken on that journey and they see the value of it and they have an input into it. That's always challenging because everyone's going to be impacted in some little way by changes. And then lastly, there is a lot of theories, hearsay, we believe this is the case, that are sometimes treated as fact. And so an element to the working groups proposed was, well, we'd like to actually start making some decisions based on real metrics and real data. And so the outcome of this was 4 nominally working groups. A couple of these are pretty straightforward. There is the rent or bounding our state size one. That's Alexi has taken the lead on that. The eWASM, for those who've seen and know a little bit about 2.0, eWASM is on the roadmap for 2.0. And as we'll talk about, the kind of goals of the eWASM group is to start to transition us towards that stage. There is also trying to deal with the growth of the data, which is the pruning state size and pruning blocks and logs. And then finally, the one that most people forget to think about, which is simulation and emulation. Let's start getting data, let's be able to make some changes to a model and see what that means. And before we go into the pieces, I think the one thing to also realise is that some of this stuff will lead into 2.0. If state size does achieve the goals that we want, we may not be able to achieve an ideal state size, state approach, a state rent approach. There might be a better way, but because of the existing network, that's a bit hard to introduce to all the existing stuff. So we can take the learnings from this and introduce this into 2.0, and again with the metrics. So we're going to start with state rent, or as it's also starting to be referred to as state fees, and talk a little bit about that. We're going to start with a level set so everyone has an understanding of what we mean by this. So if we look at the definition of state from an Ethereum perspective, it's made up of 4 elements. It's made up of a nonce, it's made up of a balance, it's made up of a code hash and a state root hash. And what I want you to think about is the 2 definitions I'm loosely using at the bottom here. People have a lot of different definitions for these things, but for the rest of this part on state rent, we're going to talk about a count state as typically one that doesn't have code. In other words, you have an account and you have a balance, and that's all, effectively. We're talking about contract state as being typically one that does have code. In other words, your smart contract. It may have, it may not have storage associated with that as well, depending on what the contract does. Okay? The problem that we're working with here is that state's around 10 gig or so at the moment. And that doesn't sound like a huge amount, but we're talking about having to keep this in memory potentially, so that's going to be a potential problem. And not all that state is actually live, is real, because dApps come and go. Sometimes there's a dApp there that's taking up state, we have to keep persisting it, but it's just sitting there. And so the actual subset of what is truly required and used could be quite significantly smaller. The impact of this, well, initially a lot of people were concerned about that physical cost of hardware, right? So if you look at Ethereum today, when you put in a contract or you create state, you pay for it as part of your gas cost, but you only pay for it once. And everyone's been thinking very heavily around storage costs. The team that's doing this is focused more on performance implications. What are the performance implications? And they can be summarised as these 4 items up here. So if you've got a large amount of state that you have to read from, then when you're processing transactions, you've got to deal with that. It's going to slow it down. The more state, the more time, more reads you may need to make. Block ceiling, same problem. When you're creating the new state root, you've still got to process that relatively large amount of state. The other ones are more around synchronization. So if you're synchronizing between nodes, you've got a large amount of state, you now start needing to pushing around networks. And as such, you've also got the potential there that if a peer is pruning their state or doesn't have all the information, the ability for you to successfully get a new snapshot and deal with that, potential failures, right, when you're trying to introduce yourself to the network. So the approach, and again, state rent's not new. This is something that was being talked about in the early days, 2014, 2015 sort of time frame. Was essentially, let's start charging on a regular basis for you to store stuff in state. Alexi's comment in a video interview he did just recently captures this for those who write any sort of code in Java or have to do it themselves in some of the older languages. Read is a form of garbage collection. Let's force this unused state that's basically helping to increase the growth of our state to be something that if you want it to be there, you need to do something to maintain it. You need to keep it alive, otherwise it goes away. So we've got that background, so the next question is, well, how do we evict state? How do we get rid of something from state? What's the drivers for this? So the obvious questions is, what do we get rid of? Something no one cares about. How do you define that? Is it when the last time someone used it? Has it been sitting around for too long? What do we define some of this element to? And then finally, how much are people willing to pay to keep their stuff there? Not all of these have obviously been answered because this is fairly new. As I said, at the end of November last year, we were just starting to talk about F1X. So things are moving quite rapidly. We've already had 2 groups of meetings and there's another one coming up towards the end of May where we're trying to get this happen. So a sense of urgency is still here, but not everything's been answered. So I want to take you through the eviction process just to help understand how this is potentially going to play out. So there's going to be your normal balance, there's going to be some form of rent balance we're going to have to introduce, right? And when you effectively get to a 0 stage, then that's a candidate for eviction, but we don't, how do we trigger eviction? At the moment it's been proposed that it's based on some sort of access, so the last time someone does something with it, tries to interact with it, it goes, these are 0, let's actually action the eviction process, right? For an account, that's pretty straightforward. It's gone, right? As we talked, by account we mean just one which state has just the balance. For a contract though, contract has more value in some ways. We have code and possibly storage. So what the plan is we don't want to truly remove all of it. We want to have the ability to recover in some way. And the proposal on the table at the moment is that we replace the existing state with 2 hashes. One a hash of the code at the time that it's being evicted, and one a hash of the storage at the time it's being evicted. Now this is not perfect. For those who are already kind of mentally thinking through some of this, one of the things that we still need to drive from a metrics perspective is, well, what gains are we really going to get? As an example, you may find that a simple smart contract that doesn't have any storage or very little storage, the replacement of the 232 bytes or the 132, well, actually no, there will be 2, may actually only be just a little tiny gain over what was there. Whereas maybe an ERC20 token contract with a big amount of storage, we could get a big amount of recovery. We don't know. Okay? And so there's a lot of questions still behind this. There are lots of more aggressive approaches, including you're out of here, it's gone and it's lost forever, and some other things that people have proposed, but nothing's really got too far down the path on that at the moment. So, okay, we've evicted some state. How do we get it back? The recovery process, and we're talking here about contracts because they're the ones that we can recover, is made up of a couple of basic steps, and I'll go through a diagram with you and hopefully that way more clear. We're going to essentially create a contract that has the storage that was there. We're going to have a contract that has the code that was there. We're going to call an appropriate method that says, can you put it all back? But to ensure that what goes back was what was there, that's the hashes, right? We compare hashes. So let's run through that. You have the original state at the time it was evicted. How you might get that could be from a full archive node. It could be that you replay the network up the entire blockchain up to that point. However you get it, you get to a point where you have access to the state of that contract, account A, at the time that it was evicted. As I said, you create contract C based with the code, so it has the code in it, and you contract S with the storage. Now, interestingly enough, I'm talking through this with Adrian, who's done the proof of concept on some of this work just recently. The lovely piece about this approach is you don't have to do the whole of contract S in one go. You could create the first part of it, and then the people involved could actually help fund the cost of returning all of the state back to the way the storage back the way it was, right? And you could also need to do that to avoid gas limits. But whatever you do, at some point, contract S calls a restore to method, or opcode, and it's going to say basically restore A from C. Okay? This is now the current state that we have on our network, and contract C has called restore to, and so obviously the hash of the code in contract C and the hash in S, and I just realised I've got those two round. Contract S is the one called restore to. I compare, and assuming that there's nothing nefarious happening in this, and essentially those two get restored. Okay? And then the last thing is to make contract S go away. Remembering it's got the big bit of storage as well. And you could, I guess, get rid of contract C, but I'm not sure if you would.
It's frowned on to self-destruct other people's contracts because it's contract S that calls restore to. We know that you're in control of that, so you can self-destruct it, and it does. The restore to is effectively a self-destruct on top of the restore, the same mechanics. You can't really do a lot about contract C unless that code happened to have something in there that let you call self-destruct anyway. So it has to be the same code as the original contract. So if that didn't have a way to self-destruct, contract C can't be self-destructed. But you can stop paying its rent and it would get evicted itself. Take out that code and leave a hash node that you don't care about. So it's not perfect, but
it's a start.
Too messy.
So the state that you're putting into contract S, so say it was some complex data structure originally, say a map with an array with a map, and something horrific like that, but some deep data structure, do you have to recreate that in the contract S? Okay, fantastic.
So bear in mind there are no complex data structures. That's a fallacy that Solidity makes you think.
Yeah, okay.
So you aren't just taking key value pairs and you've got to restore.
Yeah, so you've just got to get data in the right data location.
Yeah. And I mean that's the hash element, right? Ultimately we're comparing the hashes to ensure that what you had was what was there.
Okay, so how you probably do it is in contract S you would have a function which said set location this 32-bit value to this 32-bit value.
Yeah, exactly. And thinking it through, having talked to Brett about this presentation earlier, I think what you wind up with is actually probably a restore kind of contract, which is a generic contract you deploy somewhere that is set up specifically to restore something, and it's kind of got methods to let you say, here's a bunch of data, start putting it in, and when it's ready, go to its thing. And packages it up in a nice, easy to use way so you don't have to understand all these details.
And hopefully that happy reusable piece of code will be evicted.
But yeah, you have to deploy it each time for each one, but it will get evicted every time.
Yeah, but it's basically a pattern, right? You're going to say you need to restore something. Here's the code that you use. Drop that in as S, and then start populating it with these methods that are already built upon it.
Okay.
So as we get to the end of kind of the state rent bit, there's some challenges, obviously, some of which we just talked about, which is there's still questions. Because the current contracts that exist on Ethereum today were built with completely different assumptions. They were, I deploy this once, I pay this gas fee, and I am here forever, thank you for coming. Okay? The other one is most of the contracts having, from what I understand from Alex's analysis, are potentially susceptible, vulnerable, what's called a dust griefing attack. Now I'm going to kind of hopefully explain this to most of you as the way I understand it. Let's take an ERC20 token contract, right? There is two methods that they all have to have, which is transfer and approve. The interesting thing about approve is you don't have to, it's kind of anyone can call approve. So what you could, as a bad actor for a relatively small gas cost, could effectively inflate the storage of an ERC20 token that everyone wants to keep, thus causing its rent cost to go up. Because if the rent's based on how much storage or how much state you take up, I just have to sit there being very nasty to your contract, causing you more and more money to be spent to keep it around. So there's going to have to be questions as to, well, how many of those things exist? How do we deal with that? And then the last one is there is quite a certain amount of interdependencies between contracts already that exist on the network. So how do you upgrade them? Well, if you upgrade one and it has rent and it needs to be changed so that this other one can now also have to be changed to know about the new one, etc. So there's going to have to be some level of upgrade process and grace period by which contracts are modified to deal with rent, but not actually evicted at this point. So this could take 6 months to a year or more before you actually flip the switch and stuff starts getting evicted. Once we actually agree that this is how we're going to do it. Okay, everyone got that one? This is the big one. This is the one that has probably the most impact on so many people, and has impact on performance, not so much on storage.
Has anyone done analysis of which contracts are updated? Because obviously there's no way of doing analysis on which contracts are viewed, but which contracts are actually updated regularly?
I'm not sure. I went through some of the paperwork and the stuff that Alexi had pushed out already, and there's been a fair amount of, by the sounds of it, him looking at some of that data, which is why he made this comment in the middle here about a lot of contracts will be potentially vulnerable. There's also that question of, well, we don't really know how many contracts are big enough that the savings will be significant, but I don't know how much analysis has been done. I have to say, up front, I've gone to a level here, and the people that are running these things are down here somewhere talking about stuff that would take up an entire hour or more presentation alone. Yeah. So I can't tell you that answer, I'm sorry.
Yeah, okay.
So let's move on. Let's talk about eWASM, the second big one that's on the list here. And to do that, we have to have a bit of an understanding of precompiles. People from Pegasus can have a nap. So precompiles are virtual contracts, but they're developed and created within each client, Ethereum client, right? And the reason for that is because they're introduced to deal with operations that would be too costly economically, or even potentially feasible within gas limits, to write them into your smart contract. An example is something like, say, a SHA-256 hash. You may be able to write it in Solidity, but the cost of running that in your EVM, in your Solidity code, is a bit too expensive. So what's been done is we introduced these precompiles so that when you call them on a client that supports that precompile, it runs native code in the client. Okay, and there's a stack of stuff behind that. So the problem with that, you can see it coming, is essentially we are pushing a fairly significant burden onto the client manufacturers and the core devs whenever a new precompiles are supplied. And in fact, one of the delays of Byzantium was there was enough precompiles that all had to be implemented by all the clients out there so that we could hard fork at a given time, because until all the clients are prepared, you can't, if hypothetically client A is not prepared and the hard fork happens, then anybody running client A can't participate anymore because it's not ready for it. Okay, so you've got that problem, and as I said, the other element there is that actually implementing one takes a lot of time, part of which is also the benchmarking. How much gas do you charge for this precompile? And it's not, necessarily a fantastic mathematical approach. It's benchmarking and coming up with an agreed upon gas amount that you charge for actually running that code. What is WASM? And apologies to those who saw the talk last year, just kind of stole a bit of this. So WASM is WebAssembly. It's been around for quite a while. It aims ultimately to operate at near native speeds, and it's supported by the open standard community. It's got a lot of languages it supports, including C and Rust, and there's quite a few different implementations. And part of what WASM was all about was that ability to write this piece of code and run it on web browsers and maybe on native hardware or other things. So basically, write once, run everywhere kind of approach. We all know how that sometimes ends. But what's eWASM? Well, eWASM is the Ethereum version of that. And what do we mean by that? Well, there's a couple of key important things that you need to be able to do in the EVM, in a piece of code, that you can't do in WASM necessarily. And one of those is you need to remove non-determinism. It needs to be deterministic. And secondly, you need to be able to support metering. You need to be able to stop something from running way past what its gas limit is, for example. How do you stop it? So the definition of basically metering is just that. It's the way in which we can calculate deterministically what something is going to cost to execute. And one of the key non-determinism components within eWASM is floating point. Okay? So the goals of the eWASM team, which by the way is, well, it's being headed up by a guy whose name's just suddenly gone out of my head. It's also the whole eWASM team that's been around for a little while pushing, we want eWASM on the, replace EVM with a eWASM virtual machine, have these essential components to it, right? So we want much quicker, simplified process by which new precalls can be added into a hard fork. We want to have a deterministic way in which we can calculate what the gas of a new precompile should be charged at, as opposed to this, let's run many benchmarks and it'll cost this. And essentially it's, as I mentioned earlier, that gateway to let's start playing with eWASM and getting eWASM into the Ethereum network, ultimately replacing, the EVM. There's two approaches that have been kind of, and again, like Ethereum 2, when we talked about that last year, and like I said at the beginning, this is all in a relative state of flux. There's a lot happening at the moment, and I encourage you, if you have an interest in this, to talk to some of the people in the community and participate, because there's some links I can show you at the end. But the two approaches are this. One, if we have a WASM or an eWASM compiler built into our clients, that means that if I have a new precompile, I can write that and share that to all the clients, and they can just take it and run with it. Right? Instead of every client has to implement the version of that precompile. So we still require a hard fork though, so that's one problem. But it does mean that we potentially all implement the same thing. The other one, which is where the last precompile term comes from, is that we create an eWASM precompile. And then your Solidity contract can pass, as a call to that precompile, WASM code. Okay, and it gets executed, remembering that the precompile is native code in terms of your client, it gets executed on the client. Now, there's potential there for a couple of things. The obvious one is it increases our state size for that contract because it's bundling that bit of WASM code and shoving it through. There is potential for or possibilities where we could, maybe the precompile has a way to store really useful contracts or really useful opcodes that I create so that anyone else can then access them. So there's a lot of how does this work? But yeah, there's a certain amount of excitement within at least the eWASM community about how this might move us forward. So their deliverables really can be categorized by this when I look at their proposal. They want to put specifications out in terms of EAPs. They want to do a prototypal support of this in some way on a client today. And then they want to implement all the existing Byzantium ones to prove that this could have, we could have implemented these precompiles in Byzantium in this method. Most likely in Rust or possibly C. And then finally they want to implement some new precompiles. There's a number of precompile suggestions out there that people would love to have. Ones that support, again, mostly around the cryptographic processes, ones that support Zcash or ZK snarks, or that would be more useful or very beneficial to those areas. And then finally, of course, if they achieve all those goals, they're going to have some sort of tutorial to help the rest of us write these things. Yeah, you've got a question. I can hear you. I can see the brain going there.
I've got all sorts of questions. But okay, so you've got some Solidity code, and it's going to call to this eWASM code. But you've say here's some arbitrary code, and here's some data. Come back when you finish computing it. How does, at the moment, when you do call a precompile, you call the precompile, or before you call the precompile, it says, I'm going to deduct the amount of gas it's going to use, and then if we've got enough gas to get to call it. With this, you're not going to know how much gas the precompile is going to use because it's eWASM.
I would have to think you would, because the whole point of it, and I'm going to guess here, Adrian hopefully will tell me differently, deterministically, right? I mean, if we can Isn't that the whole point of this?
No, so eWASM would be as open-ended as the EVM. You wouldn't know what the code's going to do because you might be looping through an array, depending how long the array is, type thing.
Yeah.
So there's no rule that says a precompile has to have a fixed gas cost. They just all do at the moment. Because at the moment they don't at the moment because some of them charge more for the length of input data.
Oh yeah.
So there's no reason you can't just be implementing in a way that it requires, can decrement your gas counter as you're going.
Okay.
Or you treat it like a call to another transaction or to another contract where you give an allocation of gas and then you can wind that down, whatever it doesn't use, you kind of get back up. So there's probably a few ways to do it. I think there's a number of open questions around it too.
Can you update?
For somebody who's more doomed to it.
Yeah, definitely porting Doom is an open question.
Can you update state from within within the precompile?
I have no idea.
No technical reason you couldn't if the operations existed in eWASM. I don't know whether they do or not, but I kind of hope they add it.
I believe, again, just trying to mentally parse the documents that I've read recently and some of the videos I watched, I'm fairly confident there were elements and questions in there we need to work out how to, so some of the challenges of course is, how does that eWASM precompile communicate with state?
Yeah.
Right? And I mean, if you think about it, that's what we have. Our existing precompiles have to interact with state.
None of them do.
Yeah.
None of them do? Okay, they could though, right?
Yeah. I mean, they've got the full client. They can do anything. So often, when you do, like, I think even Quorum does this, and certainly the private transaction support in Pantheon is kind of this magic world. You can call a precompile from what public chain sees, and you've got the private support. The client just goes off and does stuff. It can create whole new world states, do anything it likes.
Yeah.
They are without restriction.
Yeah. It sort of does. So at the moment we've got the EVM, and we've got to worry about breakout of the EVM, doing nasty things. And now this would be introducing a new area, completely new area where we can break out of.
Of course.
So nasty people with attack code and such like.
I mean, if you look at the 2.0 roadmap and the plans there was to introduce, to basically replace EVM with an eWASM.
Yeah.
Right. This is kind of a halfway house, and in some ways we're taking some stuff away from people, and it's nice to give some people some things back, if you know what I mean, on this journey, without saying too much more than that. But I can see why they want to get this in there, and let's be honest, there's been a lot of push and requests for EVM to at least get on the roadmap for 2.0 for a while. So I have no doubt, and was not there, that there were people there going, here's an opportunity to get the eWASM in the door earlier than wait for the 2.0.
Yeah.
There will have to be questions, because ultimately, even if we implement however we implement this, all clients are going to have to agree to implement eWASM for this to work. Right? Whether it's the last precompile or whether it's you now have an eWASM capability that you can take precompiles that someone else builds or eWASM code that someone else builds and contributes to all of the clients so that we can move the precompiles through faster. Whatever it is, it's going to affect clients. And as I say towards the end, and I'll just remind everyone towards the end, the first two ones we've just seen are going to require hard forks to be able to do. So yes, there's going to be a lot of questions, and the core devs are going to ask a lot of questions about this stuff. I mean, we all think about security in one way or another within the product we build. Okay, let's keep moving, conscious of time. Chain pruning. So this is really about the storage requirement of a node. So if you look at a full node, it has a number of things it needs to store. It's got the headers, the block bodies, receipts, and usually some sort of indexing that allows us to match all this together, right? There's also the state, but we've talked about state, so we're not talking about state in this particular instance because it's all about the first 4 items up there on the list that this group is focused on. This little thing comes from the end of November in the original proposal that the team put together, and it gives you a rough sizing of what the actual storage requirements of a full node are today at that time. So probably a bit more than that now, at about 113 gig. Then extrapolating out based on some simple assumptions around the sizes of the header, which is actually quite small compared to the rest of it, and the block growth, which at the time was stated to be about 6,100, and if you look at historically over the last probably 6 months or more, maybe longer, it's pretty much stabilizing at around that 6,000 mark. So it's not a bad assumption. You can see that by the time Ethereum 2 is potentially going to turn up, worst case scenario in 5 years, we're adding an additional 0.5 terabyte requirement for any full node to be able to operate. So and that's not assuming we get a factor of 2, 5, or 10 times growth in this, which of course everyone would love to see. So, you know, if we do end up with that, you can imagine these numbers getting really big really quickly. And what does that force on anyone who wants to run a full node, anyone who wants to play in the space? What does that mean?
And what does Moore's law and the reducing price of storage suggest that will look like in 5 years? Is it still a relative increase of what we're paying now, or do they have available?
Look,
it probably is.
It probably is, but again, I think the comment that I read specifically around Moore's law is so much of it at the moment, everyone is going, yes, it's growing, but you know, Moore's law means that it should be okay. But what if it's not? Sorry, yeah, it's hand waving. Yeah, and you know, there's a lot of.
Well, there's also communications bandwidth as well. I mean,
It's still coming.
you know, even if we're on the NBN, I think downloading 0.5 terabyte to sync a node is going to be.
Yeah, we'll get to that. Yeah, yeah, carry pigeon. So.
Most of USBs.
Yeah, exactly. On a carrier pigeon. ABC did that a few years back. It was fun. So the questions that need to be asked around pruning are ones like this. So how much history does a full node really need to have? If a user doesn't care what their balance was 4 years ago, do they care what the transactions were that occurred 4 years ago? And if they don't care about that, do they care what contracts were actually being run at that time 4 years ago? So, and of course, if not, then we could basically just delete this historical information. But what does that mean? If the answer is yes, we could do this, we can kind of go, is we're now putting in a hard guaranteed cap on the size of storage required to run a node. Okay? But there's some requirements, and no matter what we do. The first one is data retention policies have to be agreed upon by any client that implements this. Because if you have a situation where, you know, some majority of clients prune at a certain stage and the minority of clients need information beyond that, who are they going to talk to get it? So it's going to make it very hard for them to participate in the network, if at all. The important reason why that number one up the top there is, unlike the previous two which require hard forks, pruning doesn't. There is nothing to stop an Ethereum client today from going, you know what, I don't want to keep anything beyond 6 months of data. We're gone, right? And we don't, but there's nothing to stop us from doing this. So there needs to be a level of commitment from the community to say we're going to do the same thing. That historical data, even if we prune it, we don't want to lose it. We need that historical data in some way. It's kind of the point, right? We still need to have cryptographic proof of those blocks. We still need to have a way in which we can go back and verify that we're on the right chain, that this is correct. And then finally, whatever we do from an archiving perspective, we want to maintain the ethos of this decentralized Ethereum world that we live in, or we're creating, that anybody can get access to that information, that historic information. So the approach that was the last one I heard was simply, hey, let's just implement a pruned mode option, just pick a number of blocks, and let's see what happens. And that may be what we do. It might be a case of it's done by clients to just start to see what the impact is. When we get to the simulation thing, I'll explain why that may be something we do and would need to be done with consideration of that team. So before we go any further with that idea though, we need to think about the two of the elements I just mentioned, the slide deck before that. So historical chain proofs. We need to ensure that we can prove the past was the past even if we don't have the past. Okay? And there's two approaches that have been proposed. One of them is to basically maintain a Merkle proof, right? Which is kind of what light clients do today. The disadvantage to that is it requires active maintenance. You have to continuously update the hard-coded snapshots. Okay? The other one is to maintain the header chain. Now, that would essentially mean that we can fast sync off it, but we're no longer bounding the header chain growth. You may not quite remember the slide, but the slide with the data, if you looked at the tiniest one, it was the header chain growth, because it's the smallest piece. So the general consensus seems to be the cost benefits are in favour of the latter. It's far more beneficial for us to maintain them, but and while we won't have fully capped and constrained data sizes on our nodes, it's worth it, because it's not the biggest growth point. Okay. The next one is archiving. Well, what are we going to do around archiving? There's been two elements proposed at the moment. First of all, there's what they call extra protocols, so outside of the network, hosted in something like FTP, S3 CDNs or something like that, accessed by some sort of web requests. There's a centralized element to this in terms of, you know, the big players keep those and make them available to you. The other one is an intra-protocol storage, something we can still gain access to, possibly by IPFS or BitTorrent, and those are currently being kind of moved towards the idea of archive nodes. So if people are familiar, there's your full nodes and then there's archive nodes which contain everything. The thing there is, in this environment, they're quite important. And so then the questions that still need to be determined are things like how do you incentivize people to have an archive node? The advantage of that from a decentralized is there's nothing to stop you, outside of economics, creating an archive node and participating. Okay? The challenges. Well, the first one is one that we don't always think about. dApps expect from a node that they can filter contract events for an arbitrarily long period. Why is that a problem? Well, because they can also use that as a form of free storage. Right? Realistically, oracles are the ones that sit and look at events and enact something based on an event, and they're not looking at the past, they're just looking for what's happening. But there's nothing to stop contracts, and there's a belief that a number of contracts do today, shove things out there and then can go back and read that from the past. Well, they won't work if the past doesn't exist easily anymore. The other element there, of course, is that if we start pruning these things, it means that very fact that you will be limited as to which nodes you can go to get old data. Right? And as such, a full sync is going to be harder because there may be less players in the market who can then give you the full data. So again, like anything in this journey we've gone so far, there's still a lot of questions about how we're going to move forward with this. And I think that one of the things to take away from this so far is, while there is a sense of urgency in the community to make this all this stuff happen, and we've got a lot of ideas and there's a lot of active discussions, there's no concrete we're there yet. Okay? The last group, the one that doesn't deliver a change to the network in the most obvious way, but is, to my mind, really valuable for what we're doing, is the simulation and group. So its mission, as it was stated in its proposal, was essentially to help the mainnet community understand and analyse the protocols we've got today and make that information available for anybody who wishes to use it. To have those discussions about the code, the data, so sharing code, sharing data, be very open in what they've got access to and what information they get. And then to collaborate both with the community and the working groups. We've had a number of things here. Peter's asked a few questions, other people have talked about those as, well, what is the analysis of this tell us? Which is great, that's what part of this is about. We have to make these decisions that are going to affect the network as it is today. Let's do it with a level of understanding, not we think this is going to make a difference. So the first thing that team's been focused on is uncle rates. And for those who don't know what an uncle is, essentially an uncle or an honor is a mined block that's not part of the longest chain. And it's been usually considered to be caused by a high latency in the network. So, two of us are miners, Jason over there happens to successfully mine and start sending out that information, I mine what is ultimately an uncle block. His block becomes the next one on the canonical chain, mine doesn't. I still get some reward if a hash of my block is included in the next block under the honors list. Okay, and there's a potential there for that to have been abused by me not spending a lot of time by actually mining an empty block and just making sure my hash managed to get included in the honor list, because I'm going to get a little bit of reward for that without actually affecting the difficulty of the chain. Byzantium changed that so that uncles are now included in the difficulty calculation. So hopefully that's not a problem. But ultimately, uncle rates have been considered an indicator of network health. If we consider that the reason uncle rates are, if they're increasing, it means that there's a latency issue. But the data doesn't fill that up and tell us that. So this is a historic list of data of uncle rates. And unfortunately, I cannot completely remember what some of the peaks in the early are, because they're in the notes that I can't see here. But you'll notice that there's an increase there, which, if you reflect on the very first bit of data we had at the beginning, pretty much coincides with that ramp up of transactions starting to hit our network and starting that utilization that I showed you right at the very beginning. And then it kind of comes down for a bit, probably around the time CryptoKitties finally stopped being exciting, went up for a bit, but if you look at it now, it's now heading down to the sub 500 sort of level. So uncle rates are dropping, and have dropped quite significantly on this fairly aggressive downturn over the last, what's that span, a bit over 6 months. So the big question is why? So some of the causes that the team have proposed or thought about is maybe data size rather than transaction count is an indicator or impacts on uncle rates. Possibly the number of miners or even the number of nodes have changed, but again, we don't know what the network really looks like. Possibly the protocol change. The Byzantium one I mentioned earlier may have had an impact, but we were already starting to see some drop-offs before Byzantium. Maybe some of the clients, their optimizations have improved, right, in terms of how they process stuff and how they actually generate the mining. And then lastly, it could be that there's some significant improvements in our connectivity. Maybe there's the mining pools have actually invested in or inadvertently reap the rewards of better connectivity between the mining pool members and the top level. Maybe the connections between the miners has improved. We don't know, and that's part of the problem. But the thing we take away from all of this is there's been a huge amount of data that the team has already started to collect to try and understand what maybe some of this is there. And so the ultimate goal of some of this is that we hopefully will be able to reach a point where we can start to model what a network looks like. And then we can maybe start to tweak pieces of it and see what the impacts may be. And one of those could be that we could increase the block gas limit. And of course that has quite a significant impact on the one we saw a minute ago with gradient pruning, if our blocks are suddenly even bigger than they are today. Or we could come away from this and go, you know what, uncle rates are a really poor way of understanding the network health, and maybe something else is. So unfortunately from this team's perspective, they've got far more questions now than they had when they started, but it's leading us to get to a point where we can start to not only ask these questions but maybe answer them in a scientific way, as opposed to it feels like things are good or things are bad. Okay. Small section on quite a valuable group. So what's next? At this moment, there is a target within the Ethereum 1.x groups to have proposals ready for May for looking at. As I mentioned to you earlier, both Rent and eWASM are going to require hard forks. Pruning probably won't. So, being able to implement that is an outcome of the other decision, as opposed to we've got to draw a line when these things will happen. But ultimately, we still have this fun part, which is getting these things debated and getting buy-in from the community. And if anyone's ever tried to organise a group of engineers to all agree on one thing, we hopefully will get a decision on this sometime around May. At least we'll get some stage process. And hopefully, as I said right at the very beginning, one of the key drivers behind all this is a sense of urgency. We don't want to be sitting here this time next year, me getting up here and presenting 1.x and going, So, I'll just replay the presentation I gave you last year because nothing's really changed. We haven't delivered anything yet. For those who wish to find out more, a couple of slides, and these slides are available on the Slack channel. The All Core Devs meeting is where a lot of this stuff happens, where you can read about this. The minutes of those are up there. The Ethereum Magicians have a ring specifically around Ethereum 1.x, again, where you can go and contribute and participate. If you're really interested in the state rent proof of concept, Adrian down the back here, who actually was involved heavily in the proof of concept work, in fact, I think the only person that did it, has written a really good blog post that goes through a lot of what he's found so far and some of the challenges still left to go with respect to that. Some of the places I went to get a lot of this stuff, the proposal sync, which as I said at the beginning was where each of the working groups had to put their proposal together, is available there, and you can read those. They are iterating. State Rent has gone through 3 versions of its document at this moment. And the Ethereum 1x pre-Stanford meetings is actually up on the YouTube channel from the Ethereum Foundation, and you can watch the 8+ hours of presentation that they have in between, so morning and afternoon, between their breakout groups. And that is Ethereum 1x. Any questions before we go to the next slide? I'll go to that slide and then I'll go back to that. No? Terrified? Awesome, so am I.
Something I made is the concept of with regards to what the state risk and so on. But say a wallet hadn't been touched for 4 years and it's been proved, what's the ramifications of a transaction happening with that then?
If it's been pruned, so
the last transaction which you participated was beyond the pruning.
Yeah, so well, the situation in that case would be you hadn't paid rent to maintain it, so it's been evicted. The ramifications are to get it back, you would have to go through that process that we talked about earlier, which would cost you gas to bring it back. And then as part of that, you'd need to top up your rent allocation so that it didn't go away again. But one of the things that people have proposed is that you could create a contract that you only use once a year. And you just pay enough that it's there, and then it gets archived, and then the cost of bringing it back is cheaper than paying rent for the whole year, for example.
I was probably just looking at the ramifications that suddenly there's another surge on crypto or something like that, irrespective of the business aspects. Whole lot of wallets and so on suddenly start trading. They may have to pay more gas to get it back, but what's the ramification for the transaction rate in general on the chain? Or, as in, we have to look up archive and whatever process.
As far as you're saying, you said the word pruning though, and you answered based on rent. So if it's pruning,
it is rent.
So if you had a wallet and you had a whole lot of transactions that had happened historically, you would only have the current state. I guess.
Yeah, I think you're talking about the state rent. Yeah.
Yeah, the state rent, but so if it goes out of state.
Yeah, the eviction process.
It has to play through.
Yeah, well, so if a wallet is evicted, as in someone's own account and your balance, then you've just got 0 balance and no nonce, so there is nothing to restore, it's gone. And so what you do is basically just deposit money, and it's just like creating an account. It's no
okay, no, sorry.
But
So the account won't be evicted.
No.
Well,
not
so an account is just deleted. It doesn't get replaced with a hashed up. There's no restoring it because you took all your money in rent.
Yeah, so one of the requirements was that one of the requirements was both
just like super funds.
one of the requirements was both your rent and your balance of 0.
Yeah.
So you didn't have anything left in there. You had nothing to pay with.
That's something that's
The one trick is that the nonce is lost. So the nonce is what stops transaction replay from happening, and so we'll need a mechanism to prevent that replay being up to, if you put money in to then replay all your transactions again, check your money in, you paid me, and transaction 10, once your nonce gets back up there. There's a couple of different ways that's possible.
I didn't want to go into the replay stuff because it hurt my head. And I have Adrian.
I think the way we'll settle after the big blow up over Create 2 and the fact that it can reset nonces as well is that we'll set the nonce when an account is created to the total number of transactions that are on the chain. So you get really high nonce, higher than any nonce could have been, and you never replay the nonce then.
Right, should I?
Yeah, so Peter's probably got more knowledge of the upcoming events, so just to share and promote those.
Yep, so next week we have applications of blockchain. So we've got Richard here.
In 2 weeks, not next week.
Good point. Good point. Next fortnight, and for those of you who don't live in Australia or another country like that, fortnight is 2 weeks. It's not a game. Okay. So applications of blockchain. We've got Richard, and we've got Frederick, who isn't here at the moment, but he will be next fortnight. He promises me. And Chris Randall is going to come down from the Sunshine Coast and tell us all about his thing that he's working on. So that's going to be fantastic. We've already got a lot of people who've said they're coming along to that, so it's going to be big. Running Pantheon, so we've got Jason who's in the green there, and he's going to tell us how to run Pantheon and how to operate that Ethereum client, and tell us all the ins and outs of that, so that's going to be fantastic. Later today, I'm going to finalise the April 20 talk. I've got someone coming along, not consensus, and better have a quick chat to them to talk to them about a few things. On May the 1st, we're going to have researchers come in, and so Sally and Michelle, I haven't actually asked you, but 6 months ago you said, this is what we're going to do. And who knows, I mean 6 months later it might be interesting to say, this is how we're going. But anyway, so we're going to be, I am going to try and hunt down and within 6 weeks' time have 3 different sets of researchers who can talk about what they've done, because that could be very interesting. And then after that we've got Ethereum development, so how to actually develop apps, and Sally is going to, and Chris is going to come down from the Sunshine Coast again. Golly, twice in 1 year, it feels great. But anyway, so that's still good, Sally. I haven't talked to you about this in recent history. Yes, thumbs up. Okay, this is good. So at the moment, we've only got these two on Meetup.com, and the rest of them are going to come along with a whole heap of others sometime, probably later today or tomorrow. So it's great that everyone's come along, and let's keep on doing Ethereum, hey?
Thanks so much, Chris.